In this video, we are going to review the midpoint formula, the distance formula, and slope formulas. Midpoint formula. Graphically, what we're doing with a midpoint is we're trying to find the middle of 2 points somewhere on the coordinate plane. So we're going to be averaging the x values together and averaging the y values together. So let's use this as our x sub 1, comma, our y sub 1. And this is our x sub 2, comma, y sub 2. So we have the first point and we have the second point. So we're going to take our first x value plus our second x value and divide it by 2. Then we're going to take our first y value, add our second y value, divide by 2. Simplify. 6 plus 3 is 9 halves. 6 over 2 gives us 3. The second question, we're going to average our x's together. We're going to average our y's together. Simplify. We get 1 half and 4. Finding the midpoint is finding the average of the x's and the average of the y's. And this new ordered pair will give you the midpoint between a set of ordered pairs. Distance formula. Distance formula will find the distance between two ordered pairs. So again, this is our x1, y1, x2, and y2. So using this formula, we are going to take the first x value and subtract the second x value. 3 minus 6, quantity squared, plus the first y value minus the second y value. Simplifying inside our parentheses, we get negative 3 quantity squared and 4 quantity squared. Those parentheses are really important in terms of the negative 3, because a negative times a negative will give us a positive. So this being simplified gives us 9. The positive 4 doesn't matter because it's just going to give us 16. There's no way that would give us a negative 16. So simplifying under the radical, we get 25, which is a perfect square, so the distance between those 2 points would be 5 units. You could take out a piece of scratch paper, try number 4, pause the video, and then check your answer. Using the same pattern as we did in number 3, we're going to do the first x minus the second x. So in parentheses, negative 1 minus 2, and then 0 minus 8. Notice that my formula shows subtraction, so you need to be careful with your subtraction symbols. So in the front, I get a negative 3 quantity squared. In the back, I get negative 8 quantity squared. Simplifying under the radical gives us 73, which is not a perfect square. Looks like it's prime, so this would be its simplest form. But directions up here do say nearest tenth, so if we take it a step further, we would get about 8.5. The last thing I want to review with you today is finding the slope. Back in Algebra 1, we used slope in writing equations. Y equals mx plus b, where the m told us how steep or how flat our lines were. So looking at this first question, the line that we're analyzing is here in red. And we want to find the slope. So graphically, we can look to try to find ordered pairs that are integers. And this is what I come up with. So now I'm trying to figure out my rise and my run. So from one point to the next, I'm rising up 3 and running forward 2. So up 3 is positive, forward 2 is positive. Double checking with the next ordered pair, up 3, forward 2. If I would have went from the first point to the third point, I would have gone up 6, forward 4. Notice how that would have reduced to 2 to 3 halves. So always reduce your slopes. In the second question, again, we need to find those integer intersections on that red line. And then we're just counting our slope. We always read our graphs from left to right. So that's -2, forward 1. If I go down to the next one, it's -4, forward 2, just to double check, and that gives me the same answer. So my slope is -2. So sometimes you'll have a picture where you need to calculate slopes, and sometimes you'll just have a list of ordered pairs. So then we need the slope formula. So again, thinking of our points as the first point and the second point, so this would be the first x, the first y, the second x, and the second y. This formula could also be y1 minus y2 over x1 minus x2. I like to get in the habit of circling my y values because I know they make my rise. So my second number minus my first number, my second number minus my first number. Simplify. If I would have chose to follow the pattern first number minus second number, like the second formula says, I would get 2 minus 9 over 1 minus 7, which would simplify to 7 over 6. We would never write our slope as a mixed number. Pause the video and try number 2 on your scratch sheet of paper. Looking at this question 2, if we do the first point minus the second point, 3 minus 0, and then in our x values we have to subtract a negative, so that minus a minus turns into plus. Same thing happens with the other direction. If we do the second minus the first, we get 0 minus 3, but then in our x values, -1 minus a minus 5 turns into a plus. And it doesn't matter in the final answer if our negative is in the denominator or in the numerator. It could also be written right in front of the fraction bar. Try these next 2 slope problems, pause the video, and then check your answers. Here are your answers. Notice in question number 4, you can never divide by 0, so the slope of that would be undefined. This concludes my review of midpoint, distance formula, and slope. You will be using these formulas in the upcoming chapters to help you understand the lessons.